My name is Phil. I'm the head of product at Edelrid, and in my hands here I hold a very cool rope. It's the Swift Protect Pro Dry, and it's basically the first dynamic rope that has aramid fibers inside the sheath. The first rope where we put all of our knowledge into it in terms of cut resistance. And with our test, we are able to prove, for example, that this rope is at a certain weight, has double the cut resistance of a rope of its diameter, basically. Or you could also say this rope has the same cut resistance as a 10 millimeter rope. Depending on the rope, of course, there are many different ropes on the market, but this is basically maybe the takeaway of this. So this rope is especially tuned to cut resistance. Certified as a normal dynamic rope, actually triple certified, so single, twin and half ropes, and still has the very stiff, very strong material aramid in the sheath. The Swift Protect Pro Dry will also be available in spring 2020, and the 60 meter coil will retail at 230 euros. We try to not touch any other characteristics, so as the name suggests, it's based on the Swift. So it has all the properties of the Swift, basically, in terms of it's triple certified. It has the Pro Dry treatment, which conforms with the UIAA Dry treatment standard. And it's Bluesign, like all of our dynamic ropes. So in terms of this, we stayed the same. Of course, now aramid is a material that is slightly heavier than polyamide. So with this rope, you get to 53 grams per meter, which is a gram per meter heavier than the Swift. But the rest of the characteristics stay basically very similar, almost the same. What maybe also is a cool side effect of the aramid is it gives the rope a very grippy structure. When you touch the sheath, you realize that you can hold on to it really well. This is a side effect of the aramid, but it makes it also like it's a very cool thing for mountain guides who do a lot of ridge climbing, where actually cutting the rope is a real danger. And they have a really small rope in their hand that they had, in the worst case, have to hold someone. So you want to have a good grip on the rope as well. And this was maybe not intentionally the idea, but it is a cool side effect of the aramid in the sheath. I also have to say, because I mean, we at Edelrid, we hate claiming something like this is 50% more abrasion resistant, and then you're asking based on what? And there's so the grippiness is something that I don't have any measurement. It's like a subjective feeling when I touch the rope, when I go climbing with it. I can't back that up with scientific data. It doesn't influence the way of belaying or the feeling of belaying in any way. As I said, the Swift Protect is based on the Swift, so it has the same diameter, 8.9 millimeters. And apart from mountain guides, I would recommend this rope for any alpine adventure where you have basically uncertain terrain, maybe granite environments, there's always the hazard of cutting edges, of sharp edges. But also sport climbing. I can think of sport climbing routes where you have certain edges, maybe chimneys and so on. So it just gives you a whole lot of additional security there. A noteworthy thought or point is that in terms of what a rope can do to be safe, of course it has to fulfill a certain standard. And we do good if we take ropes that are certified according to the European standard for dynamic ropes or the UIAA standard. But if you think about it, if I have a rope that has 6 falls and a rope that has 7 falls, it doesn't tell me anything. Or at least I don't know of any accident where a rope failed because of too many falls into it. It was then caused by an edge, caused by chemical contamination, caused by a rock fall or anything like this. So in terms of the technical characteristics of a rope, if it fulfills the standard, we have a certain security level, we have a certain safety level. Increasing falls, it doesn't really help. All the other measurements are basically not really telling me anything about the safety. But cut resistance, and this is why this topic got so interesting for us as well, because we are convinced cut resistance, this is basically a characteristic that actually makes a difference in the safety of a few ropes, or of 2 different ropes if you have to decide. And maybe if I go to the gym, I don't need a rope that is super cut resistant. So I could go for this one. But if I want to go alpine, or if I want to go in any uncertain terrain, if I take a rope that is more cut resistant, I have actually additional safety. And so this is why we're so interested in getting a test, and we have a suggestion for this test that actually makes cut resistance measurable in ropes. Then it's up to the user that can decide how much safety do I need for my adventures. We actually found, for example, one of our findings here was diameter. I wouldn't say it doesn't matter, but it is not the crucial parameter of a rope. After 5 years, we were able to answer the topic of the discussion, being like, just choosing a thicker rope is not necessarily the answer. There are different options of increasing the security or the safety of a rope other than increasing the diameter. So this one, 8.9 millimeters, has the same cut resistance as a 10 millimeter rope. So no need for a 10 millimeter rope, and you can only have to carry 53 grams per meter up the mountain. Development that involves textile materials there's a lot of trial and error, because you don't have any CAD software, you can't do simulations or something, so you actually have to do a lot of trial and error. And there maybe the first thing to decide was where to put it. So we experimented with putting it in the core, with having a sheath within the outer sheath and the core, and also having it in the outer sheath, which is the final solution on this rope. So the wear was a lot of trial and error. Also the proportion. Of course, there is a certain proportion where you have too much aramid in the whole rope, and it will just rip the sheath whenever there's like a dynamic load onto it. And so getting this right, and finally, and this is maybe the least spectacular one because it's the least visible, but the treatment. The treatment is basically the biggest secret, I would say, about making this work together. We basically had the advantage here that we made a lot of experiences also in the past with hybrid constructions. A couple of years ago we introduced the wrap line, a 6 millimeter cord, certified to the accessory cord standard, which has a dynamic core. So it would pass, it holds 2 UIAA folds in a twin rope setup. So there also the solution was aramid to make it stiff and strong at 6 millimeter, and then to kind of get this together with dynamic characteristics of the rope. Last year we came out with the Boa Gym, which was the first dynamic rope with polyester in the sheath. Polyester also is a material that is in general stiffer, but the problem with polyester as well is that you can't shrink it as much as polyamide. And the shrinking process is the most important process when you want to have a dynamic rope. And with all of those experiences with hybrid construction, so basically pairing polyamide and other materials in the rope, we already had a good starting point. And aramid is a super stiff material. There are certain trademark names that might be more common, like Kevlar. So it's very strong, but also stiff, which for a dynamic rope, not so good in general. But it has amazing characteristics on the other hand. It might not be dynamic, but of course, like I said, it's super strong. It is heat resistance, so this one actually has a melting point of over 600 degrees Celsius. Super abrasion resistant, for example, so Cordura basically. People know this fabric in their apparel is also based on different aramid fibers. So strong, heat resistant, and cut resistant. Anyone that ever cutted something with a scissor that had aramid in it would notice a difference, but it was never really scientific proven because there's a big lack of tests that actually can judge reliable cut resistance of ropes. The biggest challenge of this afterwards was, of course, how do we get aramid fibers in a rope that has to be dynamic afterwards? But maybe more important would be the question why we did it. The question why starts basically in 2014 when there was an accident in the Swiss National Mountain Guide training where 2 people were repelled and the rope got cut and they fell. They both survived, but they fell, and it was of course not the first accident where a rope was cut, but it was an accident that initiated a discussion throughout the mountain guide community, basically, whether we not should change the education in mountain guide training into the direction of using thicker ropes, because maybe the obvious thought is use a thicker rope and get more safety in terms of cut resistance. We had the opportunity of taking part in this discussion, and this is where we started to dig more into this topic on the research side, to find out what is it actually that makes a rope maybe more cut resistance than other rope. So is it diameter, for example? And also, how cut resistant are our ropes? Like what does it mean? So like I said, this thing started in 2014, and we were experimenting with different testing setups to come up with a way of judging cut resistance between ropes, but also of course as a rope manufacturer to answer the question, what characteristics in the making of ropes influence the cut resistance of a rope. And the test is one part of the story. That's what took basically 5 years to develop. And this is our suggestion now. But it would be wrong, I think, to put a number now on all the ropes. We can compare ropes now, but as long as there is no industry-wide standard, it would be a claim like our rope is 50% more abrasion resistant. So, but this is why we developed the test, and our vision is to push for a standardized test in the industry, and we are happy to share it with all manufacturers. The machine data, basically, it should be open source. We want to start the discussion in different organizations. UIAA, of course, work safety is another field where this might be interesting, and yeah, this is a little bit the vision of Edelrid here, to start this conversation and have something at the end that tells a consumer actually something relevant about safety of a rope. And a really nice side story to this rope was that it was actually quite a challenge in production because it messed up our cutting machine, which kind of proved the point of the whole product, and our development department was celebrating. Our production was quite pissed, so we also had to adjust a little bit the production process of cutting this rope. But I guess, yeah, we can't have a better proof of this product then.